All right, it's time to put everything together. And by put everything together, I mean it's time to take a look at the first derivative and the second derivative and what they tell us about how curves sit in the plane. Let's take a look at how to sketch a curve. The curve I want to sketch is f of x equals x cubed minus 3x squared minus 24x. This is the thing I want to graph, and it's very doable. There are some questions for us to consider. We will do that consideration. What should the domain of this function be? Well, it's a polynomial, and polynomials very nicely have domains of all real numbers. It is also helpful for us to take a look at where the intercepts are. Well, the y-intercept is easy enough. We plug in 0 for x, we get out 0 for y. Where the x-intercepts are, that's a tougher go. We could set x cubed minus 3x squared minus 24x equal to 0. This part tells us that there's an x-intercept at 0. This one, this doesn't factor nicely. So there's no nice way to go on this. You'd have to use the quadratic formula to see what the x-intercepts are. It's not very helpful. If this were a fraction, we'd be looking at limits at infinity, but it's not. And so instead, we're going to take a look at where it is increasing or decreasing. How do we know where a function is increasing or decreasing? Well, we figure out what's going on with f prime. F prime is 3x squared minus 6x minus 24. That's 3 times x squared minus 2x minus 8. That factors like this. And so if we were to take a look at an f prime chart, there are two key values on the f prime chart, the place where this is 0, the place where that is 0. And then using the tools we learned in class, either by substituting your favorite numbers or by looking at a picture of the derivative, we see that f prime goes positive, negative, and then positive again, which means that f is increasing from negative infinity to negative 2, decreasing from negative 2 to 4, and increasing from 4 on out. So we've considered the domain, we've considered the intercepts, we've looked at where the function is increasing and decreasing. Let's take a look at where the function is concave up or concave down. That comes from f double prime. Well, f double prime is the derivative of this. That's 6x minus 6. And so if we were to set up an f double prime chart, there's only one number to think about, and that's the value where the second derivative is 0, and we know that this is going to go negative and then positive, either by substituting your favorite number greater than 1 and then your favorite number less than 1, or by looking at a picture of 6x minus 6. It starts out below the x-axis and ends up above the x-axis. If the f double prime chart goes from negative to positive, then f is concave down for a while and then concave up. So what does this mean? Well, we would want to take a moment to see what the y value is at negative 2 and the y value at 4 and the y value at 1. Now, this gets very dicey. At x equals -2, the function is way up here at 28. And at x equals 4, the function is way down at -80. And at x equals 1, it's at -26, which means that this is probably too high. And the figure is definitely not drawn to scale. Definitely not drawn to scale. So what do we know? We know that our function f is increasing until -2, then decreasing, then increasing. So it's got to go up, it's got to go down, it's got to go up. How does it do that? Well, it spills water until 1. So it's got to go up and come down in a way that spills water. And then it holds water from 1 to infinity. So it's got to go down and come up in a way that holds water. So we have a function that is increasing, then decreasing, then increasing. We have a function that is concave down until its inflection point, and then concave up on the other side. Oh, and it's got to go through the origin, which means it's got to go through the origin. There. Now it does. So we have a graph that is increasing, decreasing, increasing where it's supposed to. That's concave down and concave up where it's supposed to, and it goes through the origin like it's supposed to. These are the things we consider when we graph a function. There will be a second video attached to this lesson that does 2 more examples for us to think about to give us a little bit more practice so that we can have these skills down. This is the most important thing for us to think about going into exam 2 because it puts together all the pieces from the last few lessons. All right, we'll see you in class.